just do another one. Let's do the center drill. So we got to call up the center drill. That's tool 3 in this case. Close our doors. Okay. Hand jog down to the top of our part. Once again, anytime you're coming down in the Z-axis, you don't want to leave that in there. You want to keep it out. So I'm going to come down until I'm too low. Go to the 1,000ths. Okay, there, now I'm too high, and just come down a little bit at a time. Okay, right there, and I can actually slide that in. Okay, so I know, once again, I'm 3 inches above my table. Okay, so now you notice that tool number 3 is highlighted in the offset page. It says the spindle is by tool number 3. So I want to come over here. Under the tool offset, the length. Okay, and I'm going to hit tool offset measure. Okay, once again, I got to count for my 3 inches on the 3-inch block. So I'm going to go minus 3 point. So there, that's how far that tool is from machine home down to the top of the table. Okay, I don't have to do anything with diameters because you never use cutter comp with any kind of a drill, center drill, tap. If you want to put it in here just so you have a reference what it is, feel free to. So you want to call it 0.125 if that means that, you know, it's an 1/8 inch center drill or 1/8 inch drill. But it does not matter for the function of the machine what the diameter is on the drill. So you would go through and measure all the tools this way. We'll do one more real quick. Okay, this time just to show the difference, we'll use a 2-inch side. Same thing. Okay. Bring it up. Okay, right there I feel the friction. So I know I'm 2 inches above the part. Back to our offset page. I want to be under the length for tool number 4, tool offset measure. But now this time we used the 2-inch side of the block, so now I'm going to subtract 2 inches and hit right enter, and that does the math for you. So you would go through and measure all the tools in your program. If you're going to run 2-3 parts at one time, you can measure all your tools. It doesn't have to be the tools that you only use in your program. You just want to measure any tools that you're going to be using for the day off the top of the part. So now we have to find out where the top of our part is in relationship to the top of our table. Okay? And there's a couple different ways you can do it. You could actually get a height gauge and measure from here to here. That's all you're looking for is the difference from here to here. Or we can use our spindle. And using the values off the machine, we're basically going to use this as a tape measure. So I'm going to hand jog it up above the part. Okay. So now I have to find where this point of this drill is in relationship to the top of our part. So just like we did, off the top of the table, we're going to find out where this part is 3 inches above. Okay, so right there, I can feel the friction. So now we're exactly 3 inches above the part. So you're going to find your calculator again. You're going to go under machine, the machine value. In this case, it says a negative 2.303. Well, we want to account for that 3 inches of that block. So we're going to take that, 2.303, add the 3 inches for the 3-inch on the 1, 2, 3 block. So that value is 5.303. In this case, if you notice, they're both negatives. We're not really worried about the negative numbers. We're just trying to find the difference between where the machine is and where that tool length offset is for that part. So now I have the 5.303, and I want to go to my offset page, and you want to make sure you're using the offset length for the tool that's in the spindle. This could be highlighted anywhere, okay? But you want to be looking, we got tool 4 in the spindle, and we want to be looking at the length for that tool. So I have 5.303, and now I'm just doing a minus 11.053, because that's the tool offset value for that tool. And I come up with a number of 5.75, okay? Now if it happens to be negative, you're just going to use a positive value because it's above, your value is above your common surface. If for some reason you were using a common surface like here and your part 0 was below, that would be a negative value. But for the most part, it's always going to be a positive value. And what you're going to do with this number is you're going to go to your work offset page. And I'm going to highlight my Z-axis if I'm using G54. And I'm actually just going to input that value, 5.75. Okay? So that's exactly the distance from here to here. So if you ever want to double check yourself, what you can do is take a straight edge, another parallel, and hold it over the top of your part and get yourself a ruler, and you should be pretty close to 5 3/4 of an inch. If this value says 10 inches something, 10.75, you know you did something wrong and recheck your numbers. For some reason, if you would input a negative 5.75, what's going to happen is your machine's just going to zero out because the machine knows it cannot drill that deep. So if you do put the wrong polarity in there, that's not the end of the world. Once again, the machine won't crash. It won't let you run. You'll find that out right away when you do your graph. So 5.75 is actual value from here to the top of our part. If our top of our part was a finished surface or we weren't doing anything, you'd be done, you'd be ready to go. In this case, we want to make sure we clean this up. We want to cut across the top of our part, and then more likely we use a face mill, and in your program you want to machine that in at Z0. So if you did in your program machine Z0 with your face mill, it would just basically skim across that and it wouldn't cut anything off. So we want to take off 10, 15, 20 thousandths off of this surface. Best place to do that is under your work offset. And what I'm going to do, if I want to take 20 thousandths off there, I'm going to go minus 0.02. And once again, let the machine do the math for you. So you hit right enter. So after hitting right enter, our value now reads 5.730. So basically, our Z0 is 20 thousandths below this surface. If you would run your program again, for some reason, maybe it didn't clean up and you have to take some more off, just come back. If I want to take another 5 thousandths off, 0.005, right enter. By doing it here in your work offset, all your tools will follow that Z0. If you do it in your program, all your tool lengths are going to be off because you're cheating the Z surface in your program and not in your work offset. So that's basically how you set all your tool lengths and get in the relationship to the top of your part to the top of your common surface.